Alright, today we are going to treat Boyle's law. Under Boyle's law, we are going to define Boyle's law. Let me define it. Now, when we say Boyle's law states that the volume of a given mass of a gas is inversely proportional to the pressure, provided that the temperature remains constant. Whatever you are going to do in Boyle's law, in chemistry, when we say Boyle's law states that the volume of a given mass of a gas is inversely proportional to the pressure, provided that the temperature remains constant. Now, when we say Boyle's law, we mean pressure and volume. You understand? This is the clear definition of Boyle's law. Apart from that, you can say that Boyle's law states that Boyle's law it is a pressure and volume law. Boyle's law states that when pressure of a gas increase, its volume decrease, provided the temperature remain constant. You understand? This is another explanation, which is definition of Boyle's law. Boyle's law states that pressure of a gas increase, its volume decrease, provided the temperature remain constant. Now, we are going to proceed to a relationship between pressure and volume. Now, we are going to look at the relationship between pressure and volume law. When we say pressure, it's seen in Boyle's law. We can say that pressure of a gas is high, and then the pressure of the pressure of a volume decrease, which is going down. Assuming here is a container. Now, if you take a look at this diagram, this is our container, and then here is a plunger. Now we are going to look at the relationship between pressure and volume. Now if you take a look, if you compress this plunger, the pressure is what? The pressure is low. If you compress it, the pressure is low, which is low. Our P is low because it is not having enough pressure to circulate. The pressure is low. And then the next diagram, this is our particles inside container. Now if you take a look from this diagram and this diagram, they have differences. Now in this place we are having P, which is pressure. Our P is high. If you take a look very well, because in this place the particles that are inside container, it's easily to push because it not has pressure. You understand? Now we are having P with low and then P in high. You understand? Now easily that you can say that this one we have high volume, which is V, which is high volume. And then here we are having V, low, which is low because it is not has enough particles that are moving inside the container. Here we are having a lot of much particle inside this container. That is why our volume is rotating inside the container in high inside container. But here if you take a look this container, because the particles that are inside container, they are very low. That is why our volume is low. And then here our pressure is high. You understand? That is the difference. Pressure low, pressure high. Volume high, volume low. You understand? Apart from that, this is the reason why we can say that P times V equals to inverse. That is the reason why we call P times V equals to inverse, because the reason why is that this, from the first diagram, our pressure is low, then the second pressure is high. That is the relationship between pressure and volume. Then our V2 is high, then our next V is low because it has it doesn't have a lot of space to circulate inside the container. The more you press in this diagram, if you press your plunger inside, our pressure is high, it is low, our pressure is low inside the container because volume it is not circulating, volume is circulate widely inside container. But the second diagram, our P is high, our volume is low. Our volume is not has enough place to circulate inside container. That is the relationship between pressure and volume. This is P times V equals to inverse because it's inversely proportional. If you take a look from the definition, where is it is inversely proportional to the pressure provided that the temperature remain constant. Apart from that, let us proceed. Since we take a look the relationship between pressure and volume now we can say that now, apart from a relationship that I have treated earlier between relationship between pressure and volume, we are having P1, which is P1 V1, which is equal to P2 V2. Now this P1 V1 equals to P2 V2. This is here before. Then after here. The reason why is P1 V1 equals to P2 V2. This is the initial stage, which is P1, which is initial pressure, and V1. Let me write it, which is P1 stand for equals to P1 equals to initial pressure. Then V1 still initial volume. Then hereafter, which is P2, which is final pressure. Then V2 equals to final volume. This is before and after. If you take a look, before and after, P1 V1 equals to P2 V2, because the relationship is inverse. It is inversely proportional. You understand? That is why we have initial pressure and final pressure, then initial volume and final volume at constant K. We can say that V proportional 1 over B equals to KT, which is constant. You understand? We are having constant pressure. Now we are going to apply this to make our formula, which is the formula of our equation in Boyle's law. Now let us proceed to example. Now, based on our example, we can say that we are having example at 1.70 atm, which is atmosphere. A sample of gas takes up 2.25 liter. If the pressure on the gas is increased to 2.40 atm, what will the new volume be? Now, this is our formula, which is P1 V1 equals to P2 V2. Now we are going to calculate it, so that I'm going to show you how to find this problem. Here, if you take the look from our example, we are giving initial pressure and initial volume. We are giving final pressure, and then we are not giving final volume. They say that let us find the final volume. You understand? We are going to say that P1 solution now we are going to say that our initial pressure is, we say that P1 V1 equals to P2 V2. Now, since we are not giving the final volume, we are going to say that divide both sides. Both sides by what? P2. Now we say that P2, and here P2. This P2 cancel this P2. Remain with what? P1 V1 all over P2 equals to V2. Now, this is our formula that we are going to calculate this problem. Now, we can say that this is our formula. P1 V1 all over P2 equals to V2. Let us sort our numbers, which is here we are having 1.70 atm times, which is 4.25 L, which is liter, all over, which is our P2, which is final pressure, which is 2.40 atm, which is atmosphere. Now we can say that this atmosphere cancel this one. We are going to say that 1.70 times 4.25. 1.70 times 4.25 liter all over 2.40. 2.40. Now we can say that 1.70 times 4 times 4.25 equal to 7.22 divided by 2.40, which is equal to V2 equals to 7.22 divided by 7.22, which is liters. Don't forget to write your L, which is liter, divided by 2.40. We are going to have 3.01 liter. This is our final solution. This is the final answer. This is our final, which is final volume. This is the formula of our final volume. All this work that we have done, this is the final answer, which is 3.01 liter. Is the final volume that you are given from the question. That is how Boyle's law, you can easily calculate this step. I just make this long process so that you can easily understand different step by step. Whenever you are given P1 V1 equals to P2 V2, you can easily find the problem. Apart from that, there is another example that you are given initial pressure and initial volume. We are then final volume. You are not given the final pressure. This is the process that you are going to apply and find the formula of P2, which is final pressure. Thanks for watching. Like the video, then comment, share to other people, and subscribe for more videos.